All right. Today we're going to continue talking about vector equations like we did in the last lesson, and we'll just look at different forms of equations: vector, parametric, and Cartesian. And then we'll do finding the intersections of lines in vector form. So review is to find the vector from A to B is B minus A. We're going to need that today. And here is the first question. Here's a vector equation. You have different notation, different vector notation. It's just to test to see if you can tell the difference. Let's write it in parametric and Cartesian form. So this is a little new. It's a vector, a position vector, and it's pointing to some location on the line. This is the equation of a line that starts at 4, -1, and then goes in this direction. So our vector equation is that's a vector equation. Then if we go to parametric equations, we just write the top row as an equation and the bottom row as an equation. Parametric equations. Then we want to go to Cartesian. Cartesian is just with x's and y's, in this case x and y, and we're going to solve for p. X minus 4 divided by 2. X minus 4 divided by 2 is p. Here we're going to go y plus 1 divided by 3 is p. And we have two equations, two expressions that both equal p. So the Cartesian equation is when we eliminate the parameter using substitution. X minus 4 over 2 is equal to y plus 1 over 3. And then we just have to review the different Cartesian forms. Let's multiply by 3. And then we could put it in general form with 3x minus 2y, and let's move the 2 over, minus 14. And that is general form. General form. If we put the 14 on the other side, that's standard form. And then we can put it in slope-intercept form. We will subtract 3x, divide by -2, and we'll get that. Okay, rewrite this in Cartesian form, and then put Cartesian form into general form. Pause the video and try that. So that's the vector form, and again, that's mu. And then we want to solve for the parameter x minus 6, y plus 3 over 4. Set these equal, and that'll be the Cartesian form, a Cartesian form. Let's put it in general form, so there has to be a 0 multiplied by 4. And that's general form in Cartesian form. All right, finding the intersection of lines in vector form. We could always change these into Cartesian form and then solve a system of equations, but let's look at this in vector form. And we'll start by writing this in, we want to go to parametric form. So we don't want to write it like that. We want the x and the y. Then we're going to take the top row, and it has to be equal to this top row. When we want the intersection of lines, we want to know when the point, this point on this line is the same as this point on the other line. So we want x and y to be equal to each other. And that's why we're going to say 3 minus 2p has to be equal to 2 plus 6t. Because this gives you the x value of this line, this gives you the x value of this line, and if they're going to intersect, then the x values have to be equal. And we're going to have 1 plus p, and over here is 4 plus t. We have a system of equations in p and t. Let's eliminate the p. So we're going to multiply that equation by 2. Add. Subtract. So we know t. Now let's find p. And we can use either of the equations. Let's use the first equation. We're going to take t and put it in place of t. Take the value of t and put it in place of t. Now we just solve for p. We're going to have negative 30 over 8, which is the same as, if we divide by 2, 15 over 4. So 3 minus 2p, why don't we write this as 8 over 4 minus 15 over 4. That's 15 over 4. That's 8 over 4. And we get let's go ahead and subtract 12 over 4. So now we have negative 2p. So I moved the 3 over as a 12 over 4. And that should give us negative 19 over 4. And then divide by negative 2. All that work and we're not done. These are not the solutions that we need. They are not x and y. So you do all this work and you think, okay, I'm done. The solution is these two numbers. But no, we need to find x and y. So we're going to go back to R1. R1 is 3, 1 plus p. And if we do all this work, we get 3 minus 38 over 8. Because we have to go 19 over 8 times 2, not just 19 times 2. We don't do 8 times 1. We do 19 over 8 times negative 2. That's how we get that. And then we're going to have 1. This will be 19 over 8 times 1, so that's plus 19 over 8. And we end up with negative 7 over 4 and 27 over 8. To be sure that that's correct, we can also use equation 2, 2, 4, plus, now we need negative 5, 8, negative 5 over 8, and then 6, 1. So I'm using equation 2 from the beginning. I'm using this, and I just copied these numbers. This will be minus, it'll be a negative 30 over 8, or minus 30 over 8. Then you have a 4. This will be minus 5 over 8. This is 16 minus 30, that's negative 14 over 8. Here we have 32 minus 5, that's 27 over 8. And 14 over 8 is 7 over 4. So we get the same point by plugging in the different values of parameters in each of the equations. And so this is the intersection. All right, pause the video and find the intersection of these lines. Rewrite the position vectors as x, a vector with x and y. Then we're going to have this equal to that. And let's just write it in parametric form, where we take the top row, and that's equal to 4 minus 3 mu. Then we'll do the bottom row, 1 plus 5 lambda, 14 plus 4 mu. Then let's eliminate mu. That means we need to multiply this by 4 and multiply this by 3, so that we'll have a negative 12 and a positive 12. Let's get to eliminated 858. Here is 63 and negative 5. If we add 5, we'll get 63. So lambda is 1. And then, using one of the original equations here, let's do negative 2 plus 12 lambda equals 4 minus 3 mu. Lambda is 1. Negative 2 plus 12 minus 4 divided by negative 3. And remember, we're not done. These are not the coordinates of the intersection. To find the intersection, let's go back to R1. Lambda is 1. Lambda is 1. And we are using the original equation. That's negative 2 plus 12 is 10. 1 plus 5, 6. Let's check with R2. Here we have mu. I'm using this equation. And we're going to say that mu is negative 2. Four plus 6, same x value, and 14 minus 8. So we get the same position vector of the intersection. So if we write it like this, these are coordinates, and then we can see that the position vector points to that point. All right, and that's it for this lesson.